This is section 3.2. This is part 2. Next type of problem. We want to graph using a given point and the slope. On this type of problem, they give you a point and they give you a slope to go with. Okay, first thing I notice is that my slope is negative, so I expect a graph that goes down. I don't know much more than that right now, but that's what I expect to have. Okay, since we're dealing with a graph, we're going to be using rise over run. Okay, and your rise is your up-down movement, and your run is your left-right movement. Okay. One other thing I want to remind you about before we start working with this, my slope is -2/3, the negative off to the side. But this is also equal to -2/3, which is also equal to 2/3. Now, most of the time we write our negative fractions one of these two ways. We don't generally do this. But knowing that these are all the same value can really help you out. This will help you, it gives you some tricks when you're doing these. Okay, so what's the first thing we want to do? We're given a point, it's a freebie. I know my line goes through that point, so I'm going to graph that point. Go to 0 on the x, go to -2 on the y. I know my line goes through that point. Okay, now here's where I can use rise over run. You can think of your slope as directions to your next point. And it's a bit like giving directions in a normal city, where you might tell somebody to walk straight for 3 blocks and then turn right and walk 2. Okay? This tells us, the top number tells us how much we are moving up and down to our next point, and this one tells us how much we're moving left to right to our next point. So first of all, let's pretend the negative is in the top. Okay? So from this point, this is my up-down movement. If it were a +2, I'd be going up. It's a -2, I'm going to go down. So that's right here. And then I'm going to go over +3. If the bottom number is positive, you're going right. If it's negative, you're going left. Okay? So from here, I've gone down 2, and I'm going to go right 3, which is this point. 2 points, that's enough to draw a line. You often will want to plot more. Maybe not because you're not confident in your answer, but more because maybe the points are really close together and it's hard to get, just physically hard to draw a good line between them. So if I wanted to, I could take this point and then also go down 2, right 3, and then I can keep doing this as long as I wanted to and generate as many points as I want. Okay? Now, why might you want to know this? Basically, we're going to reverse our directions. So imagine I start here and I go up 2, left 3. See, I get the same point. So if I wanted to from here, I could go up 2, left 3, and I keep doing that. Up 2, left 3, up 2, left 3. Now really, all you do, you need 2 points. That's it. But as you can see, this does make a straight line. And this represents the line, every single point on a line that meets these 2 criteria. It passes through this point and has this slope. Okay? Now, this whole reversing thing is really useful. Like, we were given this point, which is on the axis, which is really nice. But imagine that our starting point was down here. If I tried to use this and go down 2, right 3, I'm off my grid. So knowing that you can reverse it will help you when your given point is right near the edge and you can't do more than that. Okay, so let's try one more. -2, -4, I want my line to pass through that point and want my slope to be 4. When you have just a single number, you should remember that this is 4/1. Okay? And also, just like we did above, where you basically changed the signs on both of them, these were equivalent, I can also do this, -4/-1. Remember, a fraction is just a division, and if you divide a negative by a negative, you do get a positive. This will be what we could use if we need to reverse our direction. Okay? Start off plotting your point that you're given. -2 on the x, -4 on the y is right down here. Now I use my slope to get the next point. I go up 4, right 1. That's enough. If I want to keep going, up 4, right 1. And right here, like I said, if I could go down 4 and then left 1, and you can see that it still lines up. Draw your line. And you have your answer. The graph is your answer. Okay. Now, this textbook does something weird. They have you use a formula before they give you the formula, okay? So the formula you don't really know yet, officially, is the slope-intercept form of a line. Y equals mx plus b. This is also a formula people tend to remember and then not necessarily remember what it's used for or anything else. The m is your slope, okay? And b is going to be where your line crosses the y-axis. It is the y part of your y-intercept, okay? We're going to be using this a lot more in the next section. But for right now, we're going to be asked to use this to find the slope of the line. Now to find the slope, all we have to do is we're going to solve these for y. Okay. Then the coefficient of x is the slope. Okay, so if we look at this problem, I want to get y by itself, which means I need to move this negative x over here. So I'm adding x to both sides, and I get y is equal to x plus 4. I could write 4 plus x, that's equivalent, but I'm trying to match this pattern to make it easy. Now our slope, once we have it solved for y, our slope is the number in front of our x. Well, the understood number there is a 1. So the slope for this particular line is 1. Okay. Now, if you're going to use a graphing calculator, you generally have to move things around to get it in this form anyway. And this is what I was talking about. If you have to enter it in your graphing calculator this way, you can always tell what your slope is. This tells me that my line is going to be going up. And in fact, for reference, a slope of 1 cuts this quadrant in half. Okay, so if your slope is less than 1, it's going to be flatter than this. If it's bigger than 1, it's going to be steeper than this. The same thing goes in this direction for negative 1. Okay, let's try this one. 3x plus 4y is equal to 12. I want to find my slope, so I need this y alone. So I'm going to subtract 3x from both sides. That gives me 4y is equal to negative 3x plus 12. Okay, now we want y by itself, not 4y, so I need to divide. Normally we would say divide both sides by 4, but it makes it a little bit easier if you recognize that you can just divide everything in it by a 4. Okay, so when I write my answer, well, I simplify this. I mean, y is equal to negative 3/4 x plus 12 divided by 4 is 3. This is enough to really easily graph your y-intercept. It's going to go through 3. You have your slope, which is what we're looking for here, is negative 3/4. A common mistake is to include the x. The x is not part of the slope. It is just the number in front. Okay. Now for this one, y equals negative 3x. The formula we're used to is y equals mx plus b. And at first you might not think this is in the right form, but it is, because you could always add a plus 0 here. If you think about adding 0, it doesn't numerically change anything, right? But it does make it in this form, y equals something x plus something. In this case, our y-intercept is just going to be 0. It's going to go through the origin. And this right here is our slope. So slope is equal to -3 on this problem.